The ammonia is present in small quantity in the air and the soil, which has been formed by decay of nitrogenous organic matter. It consists of one lone pair of electron and three bond pairs of electron. This lone pair of electron will be pulled towards the nitrogen atom, thereby it forms a complex compound in the ammonia. In every analysis, we are using ammonium hydroxide as one of the common chemical where the ammonia which has been dissolved in water to get ammonium hydroxide. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called the P block elements. Under that, we have discussed about the trends in their chemical properties and we have learned about the anomalous properties of nitrogen, and also we have learnt about the preparation of nitrogen, physical and chemical properties of nitrogen, and also we have discussed about the uses of nitrogen. Today, let us step up with the next topic of this unit by understanding the preparations of ammonia. So, these are the compounds of nitrogen, right? Yes, we are going to understand the preparations of ammonia and physical properties of ammonia we are going to understand. In addition to this, we are going to understand what are the chemical properties of ammonia, how it will react chemically with the other elements to form a compounds of ammonia we are going to understand, and finally we are going to understand the uses of ammonia and preparations of nitric acid. Again, it is a compounds of nitrogen. Let's see how we can easily prepare the ammonia. So, already I have explained that ammonia is a compounds of nitrogen. Is it right? So, let us understand how to prepare this ammonia. There are three methods will be there. In the first method, the ammonia is present in small quantity in the air and the soil, which has been formed by decay of nitrogenous organic matter. So, example is urea, where NH2CO NH2, which is going to react with the water molecule to form a ammonium carbonate, which is upon further decomposition reactions to give a ammonia with the water and carbon dioxide will be released out. So, by this process, we can clearly understand that what all the ammonia which is present in a small quantity, especially in the air as well as in the soil, that can be decomposed very easily. Example is, you can take with the urea, where NH2CO NH2, which is react with the water molecule to form a sodium carbonate. Later, this ammonium carbonate will undergo decomposition to give rise to the ammonia, and carbon dioxide gas will be released out. We have one more method. On the small scale, ammonia is obtained from ammonium salt, which decomposes when it is treated with caustic soda or with a lime. The second method is, it is also a small scale process where you can easily prepare the ammonia by taking ammonium salts. Here I have taken ammonium chloride and ammonium sulfate. When ammonium chloride react with the lime or with caustic soda, here I have taken the calcium hydroxide. What does it forms? It forms the ammonia with the formation of calcium chloride, and water molecule will be released out, where you can clearly understand that this ammonia will loses one of the proton to form ammonia, and this calcium combines with the chloride to form a calcium chloride, and remaining water molecules will be, this OH will take one of the protons to form a water molecule. This is where you can easily prepare this ammonia by using this ammonium salts. Here we have taken with salt, we have taken the ammonium chloride salt, okay, and we have used the lime water, which is nothing but a calcium hydroxide. We have one more method by taking the ammonium salts. Here I have taken ammonium sulfate, which is allowed to treat with sodium hydroxide, which is a caustic soda. What does it forms? Again, this NH4 loses one of the proton to form a NH3, and this sodium combines with the sulfate and to form a sodium sulfate. Again, one of the proton combines with this OH and forms a H2O. Like this, we can easily prepare the ammonia in a small scale process by using the ammonium salts as well as with the lime water or with caustic soda. Hope you all understood with the first and second method. We have one more method, which is the most important method, where in the examination it has been asked for 3 marks. So how do you prepare or how do you manufacturing the ammonia? By Habers process, which is one of the important process where you are going to prepare the ammonia. First, I'll explain with the theory process. Later, I'll explain with the diagram. Okay. So, the compressed mixture of nitrogen and hydrogen in the ratio of 1:3 at a pressure of 200 atm is passed over the catalyst at 700 Kelvin. The catalyst is iron oxide, which has been mixed with K2O or with Al2O3 as a promoter. The 15 to 20% of ammonia is formed. The gas mixture is cooled to get ammonia. Unreacted mixture of the gas is recycled. Where you can clearly understand that we have taken the nitrogen and hydrogen in 1:3 ratio as a mixture, which will be passed with a catalyst, which consists of a promoter, and this gas which produces the ammonia, which is a gas. Later this gas will be cooled to get a liquid, okay, which has the change in enthalpy of minus 46.1 kilojoules per mole. Note, earlier finally divided iron was a catalyst will be used with the molybdenum as also a promoter. Nowadays, the iron will be used as a catalyst, iron oxide as a catalyst, but the promoter has been replaced with aluminum oxide as well as with the potassium oxide. Okay, so we'll understand through the process. Okay, here we are taking the nitrogen and hydrogen gas in a 1:3 ratio, and this mixture of the gas which is allowed to pass through the compressor. Later it will be pumped to the catalytic chamber, where the gas is mixed with iron as a catalyst, iron oxide as a catalyst, so that the catalyst which catalyzes this mixture of the hydrogen and nitrogen to form a ammonia. To form what? Ammonia. This, once the gas which has been formed, it will be cooled and condensed to get a liquid ammonia, and unreacted nitrogen and hydrogen will be pumped back. Again it will be come back to the catalytic chamber, where again it will be mixed with iron oxide as a catalyst, and the process will be continuous. I'll explain once again. Here we have a Habers process chamber, where the mixture of hydrogen and nitrogen will be taken as 1:3 and it will be passed through the compressor. Later, this mixture will be passed to the catalytic chamber, where the catalyst increases the rate of the reactions, either it decreases the rate of the reaction, as we have already understood that. Here, the catalyst, iron oxide, along with the promoter known as aluminum oxide, which catalyzes this reaction, where nitrogen and hydrogen will react themselves to form a ammonia. Remember, this gas is ammonia, which is formed as a gas. It will be passed through the separate chamber to cool back it to get a liquid ammonia. Whatever the unreacted part which is there, it is nothing but a gas only. It will be pumped back. Again, it will be goes to the compressor or to the catalytic chamber. Like this, the ammonia will be prepared by a Habers process. In the examination, no need of writing with this diagram. Okay, so just understand how to put the wordings along with the reaction. Now, let us understand the physical properties of ammonia. What are the physical properties will be there? Let us understand now. We already know that ammonia is a liquid and it is a colorless gas. Okay, once you prepare it is a colorless gas with a characteristic pungent odor. So, hope you know that in your second PUC as well as in your first PUC while doing the salt analysis, hope you know that smell of ammonia. If ammonium chloride is given to you, usually ammonia will give a pungent odor, which indicates that always ammonia will have a strong sense of smell, right? So that is why ammonia will give a strong pungent odor, and it is lighter than air and it is highly soluble in water, and aqueous solution is weakly basic due to the formation of OH minus ion, where I'm going to show a reaction. If you dissolve the ammonia with the water, it forms what? NH4 plus ion with the OH minus ion. Okay, this is usually basic in nature. Okay, then the high solubility is due to the formation of bonding with water molecule. So that is why when you dissolve the salts of ammonia, it will be easily dissolved in water due to the formation of hydrogen bonding. Then ammonia, in ammonia if you consider, the nitrogen atom is sp3 hybridized. So this is the structure of ammonia, NH3, okay, where nitrogen atom is sp3 hybridized, where nitrogen atom is sp3 hybridized. Out of 4 sp3 hybrid orbital, one which contains a lone pair of electron, hence the geometry is trigonal bipyramidal and it has a 3 bonded pairs and one will be lone pair of electron, and bond angle is 107.8 degree and nitrogen to hydrogen bond length is around 101.7 degree. So here you can understand that in ammonia, nitrogen is sp3 hybridized and it consists of 4 electrons which is unpaired. So one which is acting like a lone pair of electron, remaining the electrons which has been paired up with one hydrogen atom, thereby it creates a 3 bond pairs, okay, and 1 lone pair. Okay, so in ammonia, nitrogen atom is sp3 hybridized and it consists of 1 lone pair of electron and 3 bond pairs of electron. Totally 4 electrons will be there in the nitrogen in the ammonia. Coming into the chemical properties of ammonia, first one is the formation of hydroxide. We'll understand how this ammonia will leads into the formation of hydroxide. Ammonia is being a weak base, it forms a precipitate of metal hydroxide with a metal ion. So here I'll take the ferric chloride, which is aqueous solution, which is allowed to react with ammonium hydroxide. So what does it forms? As we are already understood that it forms a precipitate where this ferric chloride in that ferric oxide react with water molecule to form a brown precipitate, and this ammonia react with the chlorine to form a ammonium chloride, which is a salt. Okay. Similarly, if you take zinc sulfate, which is an aqueous solution, which is allowed to react with ammonium hydroxide, again zinc will combine with the OH to form a zinc hydroxide, which is a white precipitate, and you can see that this ammonia combines with the sulfate to form a ammonium sulfate. This is how when it is reactive with a metal ion, it forms a precipitate. Thereby it indicates that it easily undergo hydroxide formation. Okay, you can clearly understand with the zinc where the hydroxide which has been formed. Okay, next we have formation of complex compound. Ammonia will donate lone pair of electron towards the central metal atom to form a complex compound, and this forms a complex compound with the soluble salts of copper and silver, etc. So we know that in ammonia, nitrogen atom has 1 lone pair of electron, right? It consists of one lone pair of electron and 3 bond pairs of electron. This lone pair of electron will be pulled towards the nitrogen atom, thereby it forms a complex compound in the ammonia. So we'll understand with the example where the copper, which is allowed to react with the ammonia to form a deep blue color, which is nothing but a copper nitrate. Okay, so it is a tetramino copper. Similarly, when silver, which is reacting with the chloride to form a silver chloride, and later this silver chloride reacts with ammonia, it forms a colorless silver nitrate complex. Silver nitrate complex. This indicates that the ammonia, even though it consists of 4 electrons, out of 4 electrons, only the lone pair of electrons will be pulled towards the nitrogen atom. Thereby, it allows the nitrogen atom to form a complex compound. Thereby, it indicates that nitrogen atom can easily form a complex compound in the ammonia. Next, we have uses of ammonia. Where exactly we are using ammonia? We'll understand now. It is used for manufacturing of fertilizers like ammonium sulfate, ammonium nitrate and ammonium phosphate, even in the urea. Hope you know that nowadays most of the farmers, they'll use of fertilizers, especially it consists of nitrogen, because we know that nitrogen, even though it is abundant in the nature, it cannot be directly utilized by the plants. That is why it is artificially supplied to the roots of the plant in the form of fertilizers. Okay, and it is used in manufacturing of some of the chemicals like nitric acid, sodium carbonate, etc. And it is also used in the form of aqueous solution, that is ammonium hydroxide. Okay, as an important laboratory chemical. Hope you know that for every analysis, we are using ammonium hydroxide as one of the common chemical, where the ammonia which has been dissolved in water to get ammonium hydroxide, which is a aqueous solution. Okay, and it is also used in making of artificial sill and liquid ammonia, which is also used in refrigerant. These are some of the uses of ammonia. Now, let us understand one more compound of nitrogen, that is nitric acid, that is HNO3. Let us first deal with the preparations, how to prepare with the compounds of the nitrogen, especially with the nitric acid. We'll understand first. Okay. By the laboratory method, nitric acid is prepared by heating the alkaline nitrate like sodium nitrate or with a potassium nitrate with a concentrated sulfuric acid. So here I have taken the sodium nitrate. Instead of that, you can also take the potassium nitrate also. That is KNO3. This is allowed to react with the concentrated sulfuric acid. What does it form? Sodium combines with one hydrogen and sulfate to form a sodium hydrate sulfate with HNO3. So this is an important process where you are going to prepare the nitric acid in the laboratory just by heating the alkali. Just by heating the alkali nitrates, with the concentrated sulfuric acid, you will get a nitric acid. We have one more method, and again this is one of the important process for the manufacturing of nitric acid by Ostwald process will be asked for 3 marks. Why I am stressing this? Because from this unit, we can expect the manufacturing process of nitric acid by Ostwald process or by manufacturing of ammonia by Habers process. And we have one more method, that is preparations of sulfuric acid by contact process. All the 3 processes, which is very important, definitely anyone will come for the exam. Okay. So let us understand with the manufacturing of nitric acid by Ostwald process, which is also known as modern process. The conversion of ammonia into nitric acid, which involves the following step. The first step in this process is oxidation of ammonia into nitric oxide. The mixture of ammonia and the air, which will be passed over the palladium and rhodium as a catalyst, Gauss catalyst at 750 to 900 Celsius, when ammonia is oxidized to nitric oxide. So what we will take? We will take the ammonia, which we have taken the mixture of ammonia with oxygen in presence of platinum or rhodium as a catalyst at a Pressure about 9 bar and temperature around 500 Kelvin. What does it form? It forms a nitric oxide with the formation of water. During these changes, again heat will be released and change in enthalpy is minus 90 kilojoules. Okay. Since the reaction is exothermic, the heat of the reactions will be maintained at a temperature of the catalyst. We have another 3 steps. The second step is oxidation of nitric oxide into nitrogen dioxide. Again, this will be done in presence of oxygen. We will continue with the nitric oxide. Again, it will be react with the oxygen to form a nitrogen dioxide. In the third step, formation of nitric oxide. This nitrogen dioxide, once it is formed, it has been dissolved in a water to form a nitric acid, and nitric oxide will be, again it will be recycled back. So where does it goes? It goes to the second step. So where you are going to reuse the nitric oxide once again once the nitric acid which has been formed. Okay. So this is how they will prepare the nitric acid by Ostwald process. In the examination, the step 1, step 2 and step 3. Up to step 3 if you write with a proper balanced equation, you'll get a 3 marks. Okay. So what is the first step? First step is the oxidation of ammonia into nitric oxide. Second step is oxidation of nitric oxide into nitrogen dioxide. In third step, where you are going to form a nitric acid just by dissolving the nitrogen dioxide with the water. Okay. In first step, just we are doing the concentration work with the nitric acid. The solution of nitric acid is concentrated by distillation till the constant boiling mixture is obtained, and this strength is nearly 68% by mass. Further concentration up to 98% is obtained by dehydration with concentrated sulfuric acid. This is how for the laboratory they'll do the preparations of nitric acid by Ostwald process, and no need of writing with the first step. Up to step 3 you have to write for the exam. In the next class, we are going to understand with the physical properties of nitric acid. Thereby, I conclude my session. So, we'll meet with the next session. Till then, take care and be safe, and thank you.